Some of the greatest achievements of the scientific revolution occurred in the field of astronomy. To appreciate these breakthroughs, we must first understand the prevailing view of the universe in the 1500s. The standard model of the cosmos in 1500 came from the observations of the Greek astronomer Ptolemy, who lived in the 2nd century AD. Ptolemy taught that the Earth was the center of the universe. Importantly, scholars of the time did not believe the Earth was flat. They accepted that it was round. According to Ptolemy, the Earth sat motionless at the center, surrounded by a series of perfect, transparent spheres, each nested inside the next. Each sphere carried a celestial object: the moon, the sun, the planets, and the fixed stars, which were imagined like jewels embedded in crystal. These spheres moved in perfect circular motion at fixed speeds. Beyond the last sphere lay the heavens, the realm of God and the angels. Everything above the Earth was believed to be made of a single, unchanging, incorruptible substance called the fifth essence, or quintessence. Everything on Earth, by contrast, was composed of the 4 classical elements: earth, air, water, and fire, each of which changed and decayed. Earth and water tended to move downward, while air and fire rose upward. From the bottom, rocks, to the top, angels, existence became progressively better and more perfect. This way of thinking contributed to the idea of the great chain of being, in which all creatures and objects were arranged in a strict hierarchy. Only human beings could move from the earthly realm of change to the heavenly realm of perfection. The first major figure to challenge this entire structure was the Polish astronomer Nicolaus Copernicus, who lived from 1473 to 1543. Copernicus questioned why the complicated system of spheres and perfect circular motions did not match actual astronomical observations. He concluded that the system would make far more sense if the Sun, rather than the Earth, were at the center of the universe, with the Earth placed in the 3rd position from the Sun. This heliocentric model overturned more than 1,000 years of accepted belief. The next major innovator was Johannes Kepler, who lived from 1571 to 1630. A brilliant mathematician, Kepler accepted Copernicus's heliocentric theory, but corrected one of its remaining problems. Copernicus still relied on perfect circles. Kepler demonstrated mathematically that the planets do not move in perfect circles at all, but instead travel in elliptical orbits. Kepler made 2 other monumental discoveries. The closer a planet is to the Sun, the faster it travels. He identified a mathematical formula expressing this relationship. The square of a planet's orbital period is proportional to the cube of its distance from the Sun. These laws laid the groundwork for all modern celestial mechanics.